Okay, today we will continue on the Unit 6 test, district assessment review, problems number 5 through 9. Again, you get half credit for test corrections. We also have retests that are beginning. Those are after school for full credit, but you're going to be doing your errors here and your corrections here in this column. And you're going to put as much detail as possible to get the credit. We've already done problem 1, 2, 3, and 4. Today we're on problem 5, and we have that Nathan notices that there are two shapes in a stained glass window. We have shape A and shape B. So if we look at shape A, it's smaller than shape B. So our first question, before we even look at the questions, is are they congruent, the two figures, shape A and B? Are they the same size? Are they the same shape? Okay, well, we can look at how small shape A is. It's 1 unit here, and it is from -1 to -4 is 3 units. This shape B is 6 units. It goes from 1 or 2, I should say, all the way to 8. And down here we can see it's from 4 to 6, so this is 2. If I was to draw this right triangle here, I would see that this is 1, 1, and 1. If I was to draw this here, I would notice that that's 2, 2, and 2. So we have the same height. Let's take a look at the height of this object. The height of this object is from -6 to -10. That's, if I was to draw that, that's 4. And this one is 2. So I notice that everything that I do in this, from going from shape A to shape B, is a dilation factor of times 2. That creates a similar figure because it's got the same shape, but it's 2 times larger. So they're not the same size, therefore they're not congruent. Let's look at some of these questions. I know there's going to be a transformation question which says shape A can be matched exactly to shape B by reflecting about the y-axis. Okay, well, let's take this y-axis here, and we're going to reflect on it. We're going to have a mirror image. We have 1 unit here, so we're going to go 1 unit till we get to this mirror image. Think of this as a mirror. Here is this point. This is 1 unit over here. This is 4 units left, so I'm going to go 4 units to the right. This is 2 units left, so I'm going to go 2 units right of the mirror image of the y-axis. And this is at -3, so I'm going to go to +3 and put it here. So this is my first reflection. Reflect over the y-axis. Next it says then about the x-axis. Okay, well then I'm going to take this and I'm going to be reflecting it down. It's 3 up. Let me erase this. Because now I'm going to do it over the x-axis. This is the x-axis. So 3 down here to 3, 3, 3. And now this shape is flipped over. This is 5 up, so I'm going to go 5 down. 1, 2, 3, 4, 5. And there's 5 to here, 5 down here. So now I have this object flipped over. It's looking good. However, it's still 2 times smaller. So if I look at making it, dilating it from the perspective of the origin, everything's going to expand out in this direction times 2. It's going to get 2 bigger. So that's what the question then, it says that I'm going to dilate it from the origin by a factor of 2. Okay, well, let's take one of these points just for an example. This point right here is 1, -3. If I multiply that times 2, the point 1, -3 times, if I take both those points times 2, I should end up at 2, -6. Well, let's see where this point is. D prime. Well, if I was to call this A, B, C, and D, after my reflections, there's D, and I reflected it again, should end up with a point at here, 2, -6. 2, -6. That's right there. So that checks out. The shapes are congruent. We know that's not true because they're not the same size. The shapes are neither similar nor congruent. Well, we know they're similar, so that's not true. D, shape A can be meshed to shape B by reflecting about the origin and then shifting -3 on the x-axis and 1 on the y-axis. That's pretty complicated. I'm going to erase some of this to think about what they're saying. What are they saying here? I'm going to read it again. Shape A can be matched to shape B by reflecting about the origin and then shifting -3 on the x-axis and +1 on the y-axis. Now, in order for it to be matched, they're not the same size. So I have to undergo the dilation. Does anything in this question mention a dilation factor? And it's no. So these are not going to match exactly. I can do that, but I'm never going to dilate it. I'm never going to get this shape A to grow to the same size as B. That probably might, let's look at this next one. Shape A can be matched by reflecting it about the x-axis, then about the y-axis, and then shifting it again. And there's, again, no dilation factor mentioned. So that is also a question that you can go ahead and mark no on because you have to dilate it. This shape, A, is smaller than shape B. It has to undergo a dilation factor of times 2. And the shapes are similar, so that was true. So the correct answer on your test was A and F. Question 6. In the figure below, triangle A prime, B prime, C prime, that's over here, is the image of triangle A, B, C after transformations are applied. Okay? So we're going to take the pre-image, which is over here. The pre-image is A, B, C. Let's take a look. It looks, see where the position of A is over here, B is over here, and C is over here. It looks like it may have undergone a reflection about the y-axis in order to flip the A and the C, and then some kind of a shift, a movement a little bit down. Okay, so Or another thing we could do is we could move this guy down a little bit first. If I move it all down 2 units, move it down 2, I'd have this triangle here. And now if I reflect it this way over the y-axis, my reflected image would be here, this point would be here, and this point on the axis is here, would be over here, and looks perfect. So what your options were here, triangle, the image is a result of applying a translation 2 units down, followed by a reflection. Now let's go check what did we reflect over? The y-axis. Not the x-axis, but the y-axis. That's the vertical line here. Reflection across the y-axis. Problem 7. Okay, we have a diagram here. Lines M and N are parallel. I told you before in the study guide, in the study guide I said, okay, if they say something's parallel, mark them. Mark this guy parallel to this guy. Once we know that, they don't say anything about this line here being parallel to this line. But we do know that this transversal line here is crossing 2 parallel lines. So this line's parallel to this. So we have a thing here. This line, this transversal line, it's going to create some alternate interior angles. Well, so this angle here, angle ACF, this is F, it's hard to see, ACF, and then this angle here, DBF, are going to be congruent. Likewise, we have this line crossing parallel lines, so this angle here is going to be congruent. And then we have a vertical angle. We know that's congruent. So we have a triangle that has the same angles as the 3 angles as this triangle, but are they the same size? And the answer is no. Triangle ACF is not congruent to triangle DBF. Okay. However, we do know that they have a similar shape because they have 3 exact angles. So we have triangle ACF is similar to triangle DBF. Okay? We have here that if AB is parallel to CD, oh, there's only 2 correct responses. Well, that helps us out. It says AB is parallel to CD. AB is parallel to CD. If they're parallel, AB and CD, there are at least 2 sets of similar triangles in the diagram. Okay, well, that's true. Triangle AFB is congruent to DFC. Okay, we've already talked about congruent triangles. Just by looking at it, you can tell that that one's not congruent. Let's look at this other triangle. AFC congruent to DFB. Okay, again, they're not even close to the same size. So those 2, now we're just looking to see, we have AFC, DFB. Let's map that one out. AFC, 2 to 3 to triangle AFC, similar to DFB. So that goes 2 to 3, that one's correct. So we have our two answers, AFB. That's describing this triangle over here. This triangle. Oh, let me use a different color. Now they're describing this triangle over here. We don't know much about that. DFB. DFB is this triangle. So that's another X. Question 8 is the easiest question on the test. We know that a triangle has 3 interior angles, and they have to sum or add up to 180 degrees. So we're going to take this angle and this angle and this angle. We're going to add them up to 180 degrees. So I got n plus 20 plus 3n minus 10. I'm going to keep the parentheses for now, just in case there was ever something we had to distribute. They all add up to 180. Now I just got to combine some like terms. I'll take the parentheses off now. The things that are alike. That one, and this one. Other alike is the 20 and the minus 10. Back to it. N and 3n is 5n. And we have 20 minus 10 is plus 10 equals 180. Subtract 10. And I get 5n equals 170. I'm going to divide by 5. And finally, I'm going to get n equals 5 goes into 15 3 times. And 5 goes into the remaining 20 4 times. So now I can find all the angles. And if they don't add up to 180, then I have a test here. So this angle is 34 degrees. This angle is going to be 34 plus 20, which is 54 degrees. And now we have this one is 3 times 34. That's 12, carry the 1, 102, minus 10, 92 degrees. If I add that together, 54 and 34 is 88 plus 92. So it adds up to 180. Use the drop-down menus to select the measures for angle A and angle B. So for angle A, you should have got 54 degrees. And for angle B, 92 degrees. Another careful thing that you want to look for, this is very nearly a right angle. So that angle would have been 90 degrees in your brain. This is a very acute angle, so something around the mid-30s. This one's somewhere between 90 and a very small angle, so 54. Would make sense with just using your estimation. And the final question, question 9. Okay, we need to look at this triangle, and we would turn this triangle slightly. This is 40 degrees, 60. That's 100. This angle has to be 80 degrees. And then if we were to turn this so that they're corresponding, then we know if I redraw that, this triangle, since they're similar, if I was to draw it like that one, I'd move this would be F, and the D would be over. Let me draw it a little better. This would be your D, so that's 40 degrees. F is 80 degrees. This would be 60 degrees, would be your E. From D to E is 10. From E to F is the letter Z. And from D to F is the letter W. Okay, now we can look at them. They're in a similar orientation. Okay, so let's look. We want to choose the statements that are true. 3 over 5 equals y over z. So we have y over z, 3 over 5. Oh, well, I know if I could do 6 over 10 equals y over z. But isn't this reduce? It's a little tricky. So that is 3 over 5 equals y over z. That is true. X, here's x, equals w. Well, they're not the same size. So they're not congruent. So that means the lengths of the sides, the side lengths are not the same. So x does not equal w. W is longer. The angle of measure C is equal to the measure F. Okay, these figures are similar. So that means the angles are, we have similar figures, which means the shape is the same, and means that angles are the same. The angles are the same. So let's take a look at the position of angle C is here at 80 degrees. Angle F is 80 degrees. That's true. Finally, 5 over 3 equals W over Y. Okay, well, here's W. It's between the 40 and the 80 degree. This Y is between 60 and 80. That's not in the right position. We can't compare those two things. And finally, are the triangles similar? Yes, we've already shown that they have the same angles, the shape is the same, so that's true. That was a really difficult question to get all 3 out of the 5 right. Okay, well, hopefully you finish your test corrections. Do your best, get those turned in. High quality means full credit, half credit, and your grade should improve drastically.